First of all, welcome everybody. Great having you here. Today we're going to talk, like we said, about JWTs and NFTs. Once again, thank you for hosting this, John. Really appreciate it. Let's talk about introducing ourselves and our experience first, shall we? Because my experience with JWTs is limited in the sense that I try to hack them quite a lot. If I see a JWT, I know that it's quite often used for authorization. Some things in there like, oh, which country are you from? So are you allowed to see this content, for example? What's your age category? And all of that stuff can be in a JWT, basically. A lot of it. That's my knowledge about JWTs. I know that there's a header, that there's a payload, and that there's a signature. Different ways of signing JWTs as well. And I know that JWTs, they used to be vulnerable often to the signing with the non-algorithm, but I heard that has disappeared a little bit in the last few years because it was disabled by default in the popular frameworks. Please correct me if I'm wrong, John. By the way, I can't hear you. Maybe you're on mute, so that should be better. No, still can't hear you.
1 second, I'm booting up, I guess, a new. There we go. Is this better?
Yep, much better. I can hear you now.
Cool. I'm excited to pick your brain about attacks on JWTs. I'm on the other side. John McCoy, security engineer, AppSec, OWASP, and DEF CON communities. And a lot of my time, I'm building authentication systems, JWTs, kind of spun out from the OAuth standard and found that just JWTs and rolling your own kind of token design is basically what OAuth is, and built a few systems around it, and super interested in like how you go about breaking them. And I'm the best defender is one that knows how to break. So I'm excited to be able to talk about this space with you. Like, it sounds awesome, thexssrat. Thanks for being here to chat. I'm excited.
My pleasure. I think it sounds a lot more glamorous than it really is, like hacking JWTs, but it's like, I've tried building labs to hack JWTs on, like intentionally vulnerable JWT labs, and only then do you realize that it's really that simple often, because often it'll be like, oh, the signing algorithm set to none, let's test for that. Or it'll be like a leaked key somewhere, like for example, I've leaked keys in repositories. That could happen. So it's mostly that, to be honest, that at least for me, I don't know if anybody else has any other hacks that they do for JWT, but that's mostly it for me. I try to look for those keys, try to look for those signing algorithms to setting none, and that's about it.
And I guess also, I mean, like, the signing algorithm, if there's any temporal attack from the standpoint of like, can you replay the same one, or is it uniquely signed per request? Like Longlived JWTs, kind of again back to the OAuth thing, like if they're access ID token kind of JWTs. And also maybe we spin off and also hit on JSON attacks, because so many of these services, you have a JWT and then a vulnerable JSON API right next to it. So
yeah, in a way, it's also kind of insecurity serialization process, because of course you're trying to pass that property, and the long-lived JWTs, that's also the dangerous one. That's true. Can agree with that. Like if you can sign, especially if you can sign your own JWTs and make them long-lived, that can be very dangerous. Like what's the biggest problem with this long-lived JWTs in your opinion?
Actually, my main thing that I see developers messing up most often is if you see an access ID request and then you basically grant, okay, so you have a refresh token, and that's your long-lived in OAuth talk, and then you have your access token or your access ID token, which is like a session. And the mistake that I most often see when they get a refresh or a long-lived token, and you're supposed to take this token, turn it into a session, and give it back to the user, is they'll default to a serverless infrastructure, non-stateful infrastructure that would allow a hacker to do a type of a man-in-the-middle attack of the user sends in the refresh long-lived token and the server mints a session. And then if they're able to drop that packet and basically make it so the user never gets their session, the user will just retry automatically and remint another session. And they should be revoking and terminating the previous token and session, where like they've minted 2 tokens and there's only 1 user. Why'd you mint 2 tokens for 1 user? I don't know. It's an edge case attack.
Yeah, but still, like you say, that invalidation of the token is something that really needs to happen on things like logout, compromised accounts, password changes. There's like on anything, even if you're, what I see often, for example, is that let's say I'm a specific user and my authorization changes. Well, then my JWT might still be the same until I log out, but it should be forced to give me a new one instead of preserving the old one, because it might be a lot of applications use these long-lived tokens and they're like, yeah, let's just make a token that's valid for 10 years and we'll use that to log in. Yeah, that all of this.
And
Sorry.
once you log in, like, do you have stateful services and stateful database that keeps track of invalid tokens or hashes of invalid tokens? And it's like, it's a hard problem, especially now that we're heading towards serverless architecture, and stateful is even more challenging.
Definitely, since we're talking about that topic, it's also like passing those JWT tokens on from server to server. That can be quite the security risk sometimes, and people often don't realize that. But you can intercept those tokens on specific points as well with things like SSRF. I don't know, I can't remember, but I found a write-up around about that a while ago, and it was really interesting to see how they misused those architectures. One thing that a stupid bug that you can do for JWT, for example, is that I implemented JWT, but I simply didn't check the validity of the signature. Not that you can set it to none, it's just that you can set any signature. And this happens quite a lot, and it's because JWT is implemented in 60 different places. Programmer is implementing it. He might have 59 places which are perfectly okay, but that 60th location might have some real issues in it. And that's why it's really important to for developers at least to, in my opinion, take care of that on one central location, so you can just import that, refer to it. um, if you're developing these mechanisms, do you often resort to things like security factories?
Could you give a brief overview of a security factor?
It's like sorry, like for example, the one place that handles all of the JWT things, and then if you need it, you can import it everywhere that you need.
Oh, um, I guess you mean like a library,
Yeah, exactly.
or yeah.
Sorry,
Oh,
library.
oh,
I said
oh.
factory. I'm sorry.
Well, there. I mean, there on a tangent. There is an anti-pattern of a single auth server, but we'll come back to that. But absolutely, yeah. I mean, it's just like sanitizing your inputs. You want to have one library that does that, and I mean, just like we saw with this log4j problem, you want that one library that you can replace it, you can keep track of it, it's used everywhere in a very standard way, and so you can replace it everywhere in a standard way. So yeah, as much as possible, but yeah, I think I think I saw, I think I saw a nice interceptor design in Java that implemented it. I don't know, it's a coder that was doing coder magic above my head. And I'm like, oh, that's how you put an interceptor on I think there's I don't know. But yes, absolutely. Use a standard one library and, and and also I recommend for developers to even have a demo block or an example JWT validation code, and kind of have, if you are implementing it, here's the code to copy, have this block of comments around it, and so you can visually scan each Lambda or each API and see, oh, yep, there you go, you got it, and have a standard implementation reference also. Yeah, totally, absolutely.
Definitely, and even unit test that later on if you want. That's something that I always find interesting. And one thing that,
Yeah.
of course, like if you use JWT, then you use a good valid signing algorithm. For this, for God's sake, don't use weak keys like test or password or admin or whatever. I've seen this script recently that was brute forcing JWT token passwords, and I was like, this isn't that hard.
Nice. I mean, my opinion of JWTs entirely changed when I saw that it was in the standard to use RSA keys. And I'm like, yeah, there you go. You can have a signing authority or a read-only authority.
Definitely. Like, sorry to switch subject so much, but like, where would you store your JWT token? Would it be in like a cookie, in like a header? What's the best practice there?
So I end up with a lot of API calls. So I think I'm a security engineer, so my recommendations, I usually Google them twice and have like cited implementations to be like, I'm going to double check this before I say it. But since we're just talking, I think you pass it in the X header, and that's not cached on proxies. Yet again, don't quote me. Like, do your own research.
Do your own research for sure, always.
And I'm also a huge, you brought it up earlier about if you try to pass the JWT as a authorization with your request down the stack, that can be a problem. If you can actually put cryptographic material inside of your JWT and then sign your message with that. So if there's some way that you can sign your message, but that's a tangent. I started putting cryptographic material for the sessions or for other message level integrity inside of the JWTs. And that was a game changer for me also.
That's definitely a great idea. That's something that I didn't even consider. That makes my life a lot harder. Thanks a lot for that. Appreciate
it. I do what I can.
So yeah, that's definitely one that would go in the recommendations for me as well. Some really good recommendations already, like use short-lived tokens, expect them to be used once. Tokens used for authorization, don't use them for session management. Use standard libraries, create an example JWT that you can implement everywhere. Make sure that you don't use weak passwords. Those are already some really good suggestions, I think, to at least make it a bit more secure.
Mm-hmm. And like you mentioned, unit tests. And on my parlance, I'm like, okay, you have your unit test. Here's the security unit test. So mal sign a JWT or tamper with the payload and send it in, and the unit test needs to fail. So here's your security unit test that also a security unit test should have a log alert and be able to prove, like, can your system detect a mal signed JWT? The alert needs to trigger and pop up, and then it's a passing test.
Oh yeah, that's definitely something a lot of companies seem to neglect, is that logging and monitoring aspect, because of course, like you say, it needs to be logged, but if it's logged but not monitored, then it's useless basically. And that level of unit testing, what I think is, if you have an authorization module, if you have an authentication module, you should always, it doesn't matter what it is, you should always be writing unit tests for it. And I know that there's many different ways of writing a unit test. You can do things in you can do it really very in-depth, go atomic statement coverage condition or something like that. I can't remember all of the names, but there's like many different ways of doing it. It's just that for me, what's important is test the happy case scenario and test the false case scenario in your security use case, of course, in your unit testing. Hello, KMSec, how are you doing?
Hey, what's up, folks? I just wanted to say, great space. I'm always looking for great InfoSec spaces to talk chops about testing and all kinds of technical things. And sort of related to the JWT thing, I've been in security for like 8 years now. And when one of the first times I came across a JW, this is like a war story of mine. One of the first times I came across a JWT token, talking about this whole thing of like responding to crypto errors. There's a whole spiel about how even though you don't let anything through in the response to bad crypto, just the how you respond can be a whole vulnerability in and of itself. I mean, I'm not sure if everyone knows about these things like padding oracles and like what's the other one, length extension problems and things like that. So back when I was testing JWTs the first time, I remember a really great vuln I found where there was actually a padding oracle inside the crypto data of the JWT. So I could leak like pretty interesting, well, not leak, but get things signed and trusted that were not necessarily part of the intended JWT token. But this is obviously like a contrived example that I think probably won't crop up today because, as you say, there's people try to stick to standardized methods of doing things. I mean, but back then I think everything was a bit more wild and new. Yeah, that's all I wanted to jump in and say.
Thanks, I really appreciate that, and I completely agree with you, though. I do think that makes the difference between a pen tester and a bug bounty hunter. Because a pen tester, he has to look for that ALK non-signature bypass vulnerability, but a bug bounty hunter, he thinks I'm probably not gonna find that easy of a CVE. What I also like, maybe, sorry, before I go on, maybe John wanted to add in something as well.
Oh, it's probably implemented in the library you're using, but that brings up the kind of the classic age-old. If you do hashing and encryption, which one do you do first? How do you check it? And this would, if you have it properly signed, then you would validate the signing before processing the fields in it. Would be one of the first layer attacks to ensure. But I'm sure it's implemented correctly in all the libraries now. We're much more standardized.
Thankfully. Yeah, it was a bit of a wild west in the beginning days. What also might be interesting to know for you as a developer is that there are tools out there like JWT tool, for example, which will check for a host of known vulnerabilities like the RSHS265 public key mismatch vulnerability, the key injection vulnerability, blank password, null signature. It checks for all of these things, which is really, really useful. We can just download a tool these days and run it, but I think a lot of people don't really understand what goes on beyond that tool. So I think it would be interesting that if you use one of these tools, that you look into them as well. Just see what they're doing, see what the CVEs that they're testing is all about, so you don't just run it blindly. But just wanted to let you know that we're running automated tools.
Well, yeah. Sorry, if John wants to jump in, he can go for it.
No, you go.
Yeah, I just wanted to say one of the things I've learned in my experience with like testing is the limitation you have in just understanding a tool is that you don't really lend yourself to interesting gigs. So like when someone's trying something new with a JWT, how this affects context, how this affects business logic, the kind of things that you can pull off beyond just the things that the tool tests. You're going to miss that if you're focusing on only understanding the tool. And the recipe for me has always been to try and, like, we also have sort of automated setups for these kind of things, but you got to be able, the best way is to try to build your own JWT, build your own, setup at home, and sort of see what kind of things that can go wrong in the design decisions and just build process of the whole spiel. Of course, again, when I started out, everything was very manual. There was no Docker. There was no I was almost at the beginning of the VM sort of culture war. So for me, like, setting things up meant compiling from source. It meant like hoping your OS has like all the weird stuff that it needs to get going, and getting to know the technology was a lot more hands-on and intimate. But yeah, like if you only understand the tool, you're not going to get the gigs where people are trying new things and really pushing technology to the limit, and it's going to limit how you describe fixes as well. I think is a thing you'll miss as well.
And to build onto that, JWTs are based upon JSON. Typically, theoretically, it could be XML, I suppose. But there is JSON attacks. There is like that old magic underlying it. And yeah, like he noted, if you're using the tool, are you going to be trying things that are impossible and shouldn't work? One of my favorites that most libraries hopefully catch is if you put in your user level or username multiple times. How is that interpreted? And is it rejected? Or does it take the first one or second one? Does one language, one stack take the first one and another language takes the second one? And yeah, trying really understanding the layers that you're built upon.
One thing I'd also say is becoming pretty interesting. This might be more of a kind of academic security topic, but race conditions in web apps is very interesting to talk about. So like things where developers don't cater for when two things are happening at sort of the same time that aren't going to be spec'd in the API. So if you force multiple events and then look at, does this thing really have a stack sorted out to kind of like order them out and respond to them properly is a very interesting question to ask. And this, I think, when you talk about tools, they tend to be like linear scripts that just run through a series of checks. So race conditions are always going to be something that I feel is a little bit out of scope of a basic tool.
Mm-hmm. And if you were building a system, not that it would be a primary security unit test, but what happens if someone puts in a username that's very, very long? And what happens in these failure conditions? And yeah, race conditions, like I'm over in serverless, and it's like that's both a problem all day and doesn't exist. It's like we're still figuring it out 100%.
Those race conditions can be really nasty. Like there's this race condition in lambdas in AWS Lambda. If Lambda is starting up and you send another request, it's starting up another Lambda server because it couldn't find anything. Now that happened in milliseconds, but milliseconds is enough for me to send a JMeter script which catches maybe 50,000, maybe even 1 million requests, catches it at one point, sends it all at the same time, and a bunch of lambdas are gonna be started up. So be careful with implementing that, but it shows that tools like JMeter can be used to test for that as well. I've seen everybody use Turbo Intruder, which is not a bad tool, don't get me wrong. I just like to prefer to do it the like old-fashioned way with, I don't know, there's just something about JMeter I really like. If you open the JMeter interface, you will see like this 50s look, really cool old style.
I can't believe I never thought about jumping a cold start Lambda and just like trouncing it and seeing what happened. That's awesome.
it was just a coincidence that we came upon it, but it was a really good, because then we could cap our lambdas that like you could maximum 500 or something like that. But we didn't notice that, and it could have cost us quite a lot of money. And it's these race conditions, you should always test it on limited resources. But a lot of people, when they think about limited resources, they think about, oh, can I reuse a coupon twice? Or hey, can I use my wallet's funds so often before they drain or something like that? It doesn't always have to be that functional, of course. It can also be very technical. So I think,
I mean, the attack that comes to mind is if you had like a critical alert that was going to a cold lambda, and you did something that triggered the critical alert, and then you just flooded it with a number of competing requests under the assumption that some of the requests will have to be dropped. And it might not be in first come, first serve. So like, could you suppress a call by like sending enough competing traffic? I don't know. Yeah.
interesting. That's an interesting question. I'm gonna have to think about that a bit because I don't have the answer to that, but that's an interesting question. And like you also talked about failure conditions. I think that's also very important to realize that a failure condition can be so much more than just the functional stuff that we talk about or think about. And with regression, that is one of the biggest problems. Like as a software QA engineer, I'm gonna give you guys a great advice here. Integration points are the weakest points of an application, and regression is the enemy of all good code. Now, first point I wanted to talk about was the integration points. They are very, very vulnerable because it's like connecting K'NEX with Lego and you have to use super glue. That's often how it goes between those teams. Team A designs something, Team B designs something, they don't communicate, they don't document properly, and you have a lot of issues potential there. Regression is the second one, and I'm gonna give you guys I keep telling the story, I'm sorry, but it's just so ridiculous. Like one time I was bug bounty hunting, reading the manual. Manual said you cannot disable super admin users. I tried to disable super admin users, and it was the easiest 125 euros that I ever made in my life. And the thing is, like, it was so it's so easy to slip by your testing and QA department, something like this, but you really have to keep it in mind as well that the things like regression really matter, and that's why unit testing is so important. But it's important that it's done well, because if you just check off all of the code, that doesn't mean necessarily that everything is checked properly. Just a stupid example, 100% code coverage does not mean 100% functional coverage. That's two different things. Sorry, went off on a bit of a rant.
So to run down integration point vulnerabilities real quick, like you do a security review on your one system, and then you don't necessarily know it's going to connect to 30 other systems or how that's going to flow. And so you kind of end up with like an N squared security problem. We do security in depth, we do our best. And the real lethal part about integration points is it's typically an integration point because you're transitioning systems or security levels or trust boundaries. And one prime example is when you have an external third-party partner that you sell access to your infrastructure to. An example would be like Adidas has Adidas franchises, and someone comes and puts a pile of money down and signs some papers, and they're granted keys and access to a back-end infrastructure. And that integration point of someone that just opened a store on your backend infrastructure and their computers are now integrated into yours, you have a massive shift in trust boundary between Adidas infrastructure and that store in the middle of Chicago that some random person paid money to get those keys. And that's, yes, 100%. That's a sweet weak point to start clawing at.
Yeah, I totally agree with a lot of what's being said. Integration points are always source of a lot of cash. especially in my gig. But I think thexssrat mentioned something about the lack of guarantee that we have in trusting code in sort of security domains. And this is just a kind of like an old guy kind of point that I want to make. But when I went to uni, I did like a lot of abstract math. And one of the things I learned was that there's no complete self-consistency in math. So like there's this massive problem where all of math cannot prove everything. You can't use math to prove all of the facts in mathematics. You should be able to, but it turns out that like it might take too many procedures than we can possibly compute to prove certain mathematical facts. So what I remind myself is if that's possible for mathematics, then it is certainly possible for code. So you're never gonna, the security in depth thing, we tend to go back and forth about it as security curmudgeons, but the fact is we have to try our best, because no one can come along at some point and produce concrete proof that code will do what it does. There's just no way to guarantee it the way that it stands. So, never take anything for granted when you're testing. That's how I implement that.
I agree. I'm an AppSec engineer, so like 100%, you can't have provable code. And in security, we tend to talk about vulnerabilities, and a vulnerability is something that can happen. LangSec kind of got me out of that circle, and basically coming at it from identifying core aspects that introduce a weakness. So like XML, if your transport layer is JSON versus XML, they have a core weakness because XML has recursion and statefulness and can be turned into Turing completeness and yada, yada, like why PDFs are more vulnerable than bitmaps, right? And once, like, I try to go at the whole, like, is it secure from LangSec, where it's like, what is the core probabilistic outcomes that could occur and the weaknesses that are intrinsic in that design, and just trying to mitigate weaknesses even if they aren't vulnerabilities. We try. That's why they hire security people, right? We know the magic. We totally know what secure code is. Like, I can click and 5 minutes, easy.
Yeah, but it's like the amalgamation of everything, and I just wanted to quickly intervene because you guys said that it's really hard to determine all of the possible vulnerabilities that could exist in code, and I totally agree with you on that. But to a degree, as a tester, of course, from my standpoint, what I try to aim for is I try to guarantee the security aspects to a certain level of coverage. And I'll also say that, like, this is my level of coverage that I've been able to achieve with these quality characteristics.
100%. So, I mean, the coverage thing is very important. And I think in other kind of, again, this is a very LangSec-y thing, but as we explore code to unearth different properties, you'll see people talk about coverage and block depth and call stack depth, and all these metrics are all sort of meant to serve that, all meant to say that, like, we looked at this much code, but again, the fundamental problem is, it's going to be best effort down to a certain extent, but all these metrics are meant to say how much code you looked at, because it's meant to communicate that you hit the right target. But whether or not there's concrete reasoning that can come from that is a completely different problem, I would think. But anyway, gentlemen, I'm really enjoying the conversation, but it's getting super late and I do need to sleep. I'm going to jump off, but please keep hosting these spaces. I have a lot of fun with them.
Thank you very much, my friend.
Thanks for putting in. And if anyone else wants to come up, feel free.
Yeah, and you will also find a recording of this on my YouTube channel later on, so definitely feel free to watch that. Making some self-advertisement while I get the opportunity. Anyway, some really interesting points.
This was recorded.
It's like, I try to record all of these, but sometimes I fail miserably.
Technology's hard, right?
Yeah, and I'm starting to get old, man. I'm like 30 years old, and like soon I'm gonna be with a walking stick, you know, like get off my lawn, you darn kids. Anyway,
Just just wait till I throw out that NFTs are JWT bearer tokens.
well, that's the point that I wanted to come across as well. And first of all, I really wanted to just put this in. It's really important to understand that at different levels of the software development lifecycle, different levels of testing are required, including security. So that means that if you can, why I say this, if you're doing a bug bounty hunt and you have a broad scope, or you're doing pen testing and you have a broad scope, and you see dev dot or UAT dot or staging dot, those are the things that you might need to look after, because of course they're going to be a lot less secure. And the more you move on to development and away from production, the less secure I usually find that the code is. So that's why I'm always opposed to setting up production, testing, development, and testing environments as a public environment.
I have one kind of little tangent that, as an AppSec engineer, I try to triage where I put my effort to do security, and you can from past occurrences, you can predict probabilistic failures. So if you take something like an image processing library, like they're constantly getting vulnerabilities. Like every year or two, you'll see a major library get a vulnerability, and so you can kind of predict, like, oh, this product or this feature has vulnerabilities coming up, or this probabilistic future failure rate, right? Like same for crypto encryption, that it has a decaying security over time that's predictable. And the same with developer mistakes. If you ask 10 developers to implement AES, they're probably going to get it predictably right 80 to 90% of the time. If you tell them to do RSA, you have a 50% success rate. And it's like, oh, like AES is much easier for a developer to Google and implement on their own, where RSA is a little more like, what is a public? What is a private? Like, what is padding? What does this number range mean? So past performance, future predictions, also bug bounty.
Yeah, definitely. And like most developers don't even really know the difference between the different algorithms anymore either. It's like, yeah, AES or RSA, what the hell are you talking about? I'm just using this library and it does everything for me already. Funny story about that, by the way, about that image processing. A while ago, I was testing and I found an image processing unit that put image to text and then to speech. And you could insert your image, you could insert some code into there, and it would read out the code. So you would have remote code execution. Just a really simple vulnerability, no checking, nothing at all. I was like, come on, guys. And they didn't have a bug bounty program, but thank God they listened to my emails. Really easy to fix, just some simple validation. But still, it's important. And I wanted to get back to your point that NFTs are just JWTs. Can you elaborate a little bit more on that, please?
Sure. Let's open it up to Dark Shields real quick, and then we'll dive into that.
Hello. I just wanted to add very quickly on to what you guys were saying from a non-developer standpoint. I'm surprised, when you start to get into InfoSec in general, you come at things from an attacker standpoint, a defense standpoint, from a security standpoint. And I think that these conversations are wonderful, and they need to be. It's great that they're happening with more and more developers, but I think these conversations need to also go to management of these teams, because it's amazing to me, I've said in the past, that, how many developers are sort of just unaware of secure coding, or, not very focused on it.
I can kind of address that from the AppSec engineering perspective. One of the aspects that a good AppSec engineer does is work with the development teams and management to properly staff and allocate time and cut JIRA tickets and add cycles for QA testing for security critical infrastructure. And security being now we're in an agile world, if security has a champion at the beginning pushing for we need extra time for the developers to get best practices for implementing encryption, that like we are moving to an agile security stance. And I know where you're going. And it's under the push left umbrella. And security is actually a bake in the agile process, in the grooming, in the scoping of the features. And if done there, it gives much higher ROI to bake it in than push left.
That's great. I mean, that's exactly, what I think anyone would hope to hear. I think then, because I mean, from what you're saying, the scariest thing is that a small group of a bad management team, if you look at the sort of chain of effects, it can lead to major vulnerabilities in a major application just from not looking at it that way from the beginning. So that's great.
Totally. Thanks for coming up. Okay. You asked JWTs or NFTs, or we were going to dive into that, right? JWTs can be thought of as bearer tokens. So if this token grants you the authorized use of an API and under a certain user privilege level or access to certain resources, NFTs, at the end of the day, are cryptographically proving who your identity. And then the server can check your identity. And if the NFT or the JWT is crafted, you can actually embed the data in it that says your privilege level. And that's kind of what set my mind off, where I'm like, oh, it's a long-lived refresh token.
Thanks. Sorry, I was making coffee real quick. So yeah, I totally I like that idea, and like NFTs are making a big rise these days, and like the same with blockchain. It's like maybe we should learn how to test that because right now it's coming up, and I like to imagine it. It's like the early days of hacking, like in the very beginning, everybody was phone freaking and all of that stuff. Well, now we have a lot more information sharing and a lot more knowledge sharing, and we can do a lot more about NFT hacking as well. Like, okay, this NFT belongs to this person. Well, is there a way for me to manipulate it? Can I maybe manipulate who that belongs to? I don't know, by the way. I never checked out blockchain hacking much, but it's an interesting concept to explore, in my opinion, and I think we should definitely take it into consideration.
And yeah, I mean, I think we're still ahead of the curve where it's like I'm barely hearing about Web3 of like classic website integrating data back from the blockchain into the web server infrastructure or logic. And I almost think we're still at the the OWASP top 10 phase where it's like, what are the attack vectors for pulling data off of the blockchain? Like what denial of service? Like I almost think this is an unexplored space at this time of even what Web3 means. Like what is like I'm still looking for good authorization implementations against blockchain. So we might still be like way in the future, like 6 months in the future.
Yeah, definitely agree on that. I recently read a really interesting article where they used the blockchain to insert a cross-site scripting attack vector that was then brought up again by the web application. So that was a really interesting attack vector, just using the blockchain as a transport mechanism for your attack vectors.
Oh, was that under the malicious NFT on OpenSea?
I don't remember. Jonathan sent me the article, but it was really
Oh,
interesting.
nice.
I'm gonna try and find it out, and I'll tweet it again.
Nice. While you're doing that, I'll go into the malicious NFT. They put malicious JavaScript into a SVG file, and then when it was rendered, when someone clicked on the NFT to look at it, and it was rendered, it popped up an iframe that ran arbitrary JavaScript code under the domain of OpenSea, and it executed an Ethereum transaction request, which, running under the OpenSea domain, appeared as an OpenSea transaction. And so then if they approved it, they were approving a malicious Ethereum transaction that popped open access and let people come in and take their stuff.
Oh, that's nice. Well, at least for the attacker, I guess. That's
right. And it's something that like I have not heard of any NFT bug bounty program. Like we're so new that this is like in the 1990s when there was internet and everyone had like default passwords, and it's like we're still at the beginning phase. It's crazy.
Yeah, and like you say, NFTs are okay, but even blockchain, we're still at the very beginning trying to understand what's happening, what's going on there. And for like if you think about it, it's very simple in of its essence. Blockchain has been around, I believe, since the 80s or the 90s or something. It's been around for a long time. It's nothing new. It's just that Bitcoin was a new idea based on the blockchain. But still, even though it being so old of a concept, still new issues are possibly being discovered because nobody focused on it. Same for Log4j. Such an old application, Log4j2. Like every single Java application thought that logging was safe. Yeah, I think again, it's like even Minecraft servers getting hacked, and I'm like, oh, this is gonna annoy sysadmins for years to come.
I mean, ironically, one of the systems that I often would break of developers is their logging system. Like if they failed to do input character sanitization, that it's like once I get in, it's like one of the first things I did was blow up their logging system. And not even Log4j, just in general with just attack payloads.
Yeah, and people didn't believe that logging was dangerous back then, but logging, it's finally it's coming out that logging can be a real threat and can actually cause remote code execution.
Right. I've been joking that we always know that we're supposed to sanitize our user input. So obviously you need to sanitize and base64 encode your logs. I mean, you know, like you have to sanitize dangerous input.
Yeah.
I know how wrong this is, but it's also kind of right.
And a lot of developers will also just take like speed, like you say, they just want to develop quickly. They develop something and they don't want to push it out. They don't want to think about the security ramifications of that feature. And they have to sometimes because business is pushing them to bring business value. This is something that I've written down as well. It's like security has no business value, and at least not in the eyes of business. And that's that annoys a lot of people. I'm very annoyed by that.
Yeah, I mean, I kind of phrased it as like taxation. Like if you're a project dev manager and you allow a vulnerability, like Log4j, right? Someone 5 years ago made a choice and they're not on the project. They probably aren't at the company anymore. And it's like, would you rather release your product on time or prevent a vulnerability in 5 years? Like one of these impacts your paycheck.
Definitely. And often I understand it as well. It's like, oh, this is just an MVP program, or we're just gonna push out the MVP. You'll see about security later. But that later never comes in my experience.
Or if it even does come, they're like, okay, we locked the IPs so they're not on the internet. And then you go look in the dev environment, it's like, that's a lot of public IPs there. Like I thought you were gonna lock everything off the internet. It's like, oh, that's just a dev environment. Like, it's just EC2s unprotected on the internet. That's fine.
Yeah, throw some S3 buckets in there, why not for fun?
Make it feature rich.
Yes, exactly. Gotta have the hackers not be bored, that's important.
And kind of what you said about blockchain isn't new. 100% agree. I mean, it's a database. I mean, and now it's a database that other people are able to put arbitrary data into. It's a database that maybe can take actions on you. It's a database where if you interact with something, it can like there's coins that if you interact with them, that part of that interaction is opening yourself up to an attack. And it's almost like if you if you reclassified the database as a threat actor, and we've never done that in our design models before. We've never considered the database attacking our data access layer. Like, who would think that? That's crazy.
Definitely, like that's something that a lot of developers don't consider, that database layer, but like in my opinion, at least that how I would do it and how I do everything is I try to do security from the ground up if I have the opportunity to, of course. Because some projects they're mature, they're not gonna be able to implement security from the ground up anymore into them. But often this database layer is left out completely. But like you say, blockchain is also just a database. How do we insert that data into the blockchain? Are there certain projects which are vulnerable to a sort of code execution, maybe, some injection vulnerabilities? We don't know that. At least I don't know that. I should research it more. I'm like you, I'm blasting out things here, but I should probably research them a lot more. I don't know about those things.
And that's kind of what I'm doing in NFTs, is trying to go from the ground level of understanding what are they, how do you get into them, what are your first adopted technology stacks, what is the current state of good and bad technology stacks. And it's like it's almost like someone that's never done software engineering trying to recommend software security. It's like, how could I even comment on NFT security if I don't know what that truly is? And it's a long road. I look forward to some other like young kid just running right by me and being like, "Oh, I already did it."
Yes, being like, hey, this is how you hack NFTs, and I'm like, thanks, I didn't know that.
Yeah, DEF CON, just dropping O days left and right. Like, it'll be sweet.
Definitely. Anyway, I have to run. Thanks a lot for hosting this space. I really appreciate it. And as I
Yeah, it
said,
was really fun.
the recording will be up on YouTube in like maybe an hour or so. So if anybody's interested in that.
And just for posterity, the name of your YouTube channel and maybe a little bit about it again on the outro.
For sure. Like, my name is the thexssrat, and I try to do anything hacking related. I used to be very bug bounty centric, but right now I'm more hacking in general related. So anything you can find on there. Thanks a lot for hosting me, John. I really appreciate it.
It was tons of fun. I'll catch you around.
You too. See you later. Bye.